So 5F, which is using long wavelengths, we're going to look at the specific part of the EM spectrum which is referred to as the longer wavelengths and the longer wavelength EM waves. Alright, so if we think back to the spectrum, the longest wavelength, remember, was radio waves, and then the long wavelengths that we consider in here are radio waves, microwaves, infrared, and even visible light. So right to the middle of the spectrum, and we're going to discuss how are they used, what are the uses of those EM waves. Even though we can't see them, we can still use them. So if we fill in this table with uses of radio waves, microwaves, infrared, and visible light, we'll start with the longest wavelength EM wave, which is radio waves. What are the uses of radio waves? It's very obvious that most of the time radio waves are used for transferring sound and music and the signals from radio stations to people's cars, to the radios people have in their homes. So we're just transferring information around, usually around a city. Okay, now that's not necessarily long range. It's quite big distances in some cases. But we're transferring those sounds and those radio signals across a city. But in general, we can use radio waves for long-range communication. So the first use, or the most important use of radio waves, is communication long distance. So long-range communication via radio waves, sending information very long distances, could be around the Earth, into space to communicate with the ISS, or even communicate with probes that have traveled through space. So long-range communication for radio waves is the main thing. The next type of wave that we're going to look at is microwave, which is the second longest wavelength. And again, although microwave, the obvious use of microwaves we know is for heating food in a microwave oven. So we know that microwaves can be used for heating food. But that was actually, it was a discovery that was made by accident. It was stumbled upon because microwaves are generally, again, just like radio waves, microwaves are used in long-range communication. So we still use microwave signals to transfer information large distances into space, for example, to satellites, across cities again in straight lines, which I'll come to in a second. But microwaves, first and foremost, they were used in long-range communication again, but we then discovered they could be used for heating food. All right, infrared, we said, was thermal energy, it's heat. So what are the uses of heat? Well, first of all, we know we can use heat for heating food, but unlike a microwave oven, infrared is actually used in an oven. So you heat your food in an oven using infrared radiation. Most people at this stage know that infrared images are produced almost all the time. We can create images now, images that we can see, but we use the heat from different objects to produce an image. So thermal imaging, infrared cameras, big use today in this world. We also have infrared, we have heat treatment for illnesses, so we can use infrared for treating illness as well, using heat treatment. And also infrared, actually quite commonly mistaken, infrared is used in the remote controls of televisions. So we actually call that short-range communications. Between the remote control and the TV is very short distance. So infrared can be used for short-range communication. In the past, actually, you used to be able to send pictures and songs on a phone from one phone to another just by putting them close enough together, and there was an infrared signal on the side of the phone that would transfer that picture or the video from phone to phone. So short-range communication between devices, TV remote controls, for example, are the most common. Okay, finally, the longest of all these long wavelengths is visible light, and a very obvious use is literally for seeing things, for using cameras, photography, and being able to see images with visible light. We also communicate with visible light. Back in the old days, obviously, it was much more common to use flashing lights as a way of communication, but we still use communication today in video conferencing, for example, which is still using obviously the ability to see as visible light in communicating with other people. All right, so long-range communication also, but heating food. We've got heat treatment for illnesses, thermal imaging and infrared cameras. We've got short-range communication such as TV remote controls, and cooking your food, obviously, but in an oven. And then visible light, we use that for seeing, photography, cameras, and also communication as well. We still communicate through visible light. Now, Something else that we need to be able to do from this section on using long wavelengths is to be able to explain how radio waves are produced. So the longest wavelength EM waves, remember, are radio waves, and we need to be able to say in an exam question, how are those radio waves produced? Now, essentially, if you have a conducting material such as a metal, or in everyday life for radio waves it would be known as an antenna or an aerial, then you have an electrical current inside that wire or that aerial. Okay? If you have an electrical current in a circuit and you make the electrical current constantly change direction, we actually say that it's caused by oscillations. So if the electrical current in the circuit is oscillating, which means it's constantly changing direction or vibrating, for example, in waves, if the electrical current is oscillating, every time they oscillate and change their direction, they will produce a radio wave. So radio waves are produced specifically due to the oscillations or variations in electrical circuits. All right? Now, how do we actually receive those radio waves to then produce sound in our cars, on our radios, for example? Once the radio stations have produced the radio waves by having an aerial with oscillating current inside it, which has produced all these radio waves, all you need is another aerial or another conducting material, such as metal again, which has those electrons available to move. And when they absorb the radio waves, then the electrical currents inside this aerial that's receiving will start to oscillate as well. So if you want to generate radio waves, then you yourself have to make the electrical circuit oscillate, or the electrons have to oscillate in the circuit or the aerial. But if you want to receive the radio waves, then obviously you absorb the radio waves using an aerial again, which causes those electrons in the circuit to oscillate. So it's the same thing in reverse. You make electrons oscillate and you produce radio, you absorb radio, it makes electrons oscillate. All right? And that's the production of radio waves, and also obviously the receiving of radio waves and turning them essentially into sound waves. Okay? One last thing for using long wavelengths is the differences in using radio and microwaves, which we said both used in long-range communication. Now, interestingly, we can use radio in long-range communication around the curvature of the Earth. So a big problem, obviously, in communicating with someone in another country is that the surface of the Earth, as we know, is curved. Now, because microwaves will only travel in a straight line, there is a limit to how far we can send them, because we simply cannot get them to curve around the Earth. We can, obviously, the higher that we build our towers, then the farther we can send them, but we can only send microwaves in a straight line. Even through the atmosphere, if we were to send microwaves into space, they would go straight through the atmosphere and they would go into space fine. Radio waves, on the other hand, if we get the angle right and we send our radio waves into the atmosphere, we can actually make the radio waves refract as they pass through the ionosphere. Now, if these radio waves can refract at the atmosphere, we can actually send them around the curvature of the Earth. So we can send radio waves much farther around the Earth due to this refraction in the atmosphere. Now, the reasons that radio waves can refract off the atmosphere but microwaves won't is just simply because they have different wavelengths. So radio waves have longer wavelengths than microwaves, which means that they interact with the atmosphere differently, and therefore they do refract off the atmosphere, but microwaves will only go in straight lines and pass straight through. Now, that doesn't mean we can't use microwaves to communicate around the whole Earth, because obviously nowadays we have satellites which are traveling around the Earth. If you send microwaves through the atmosphere, straight through the atmosphere into space, they're received by a satellite in space. They can then be sent back to the Earth in a different location in a straight line and received on the Earth in a different part of the world. All right, so radio is, obviously it's easier. We don't need satellites to send radio because we can get them to refract off the atmosphere and send them around the curvature of the Earth. But microwaves, obviously, because we have those satellites today and we have that technology, we can send microwaves straight through the atmosphere in a straight line, received by a satellite, and then sent back to the Earth at a different location. So both used in long-range communication. Radio, on the other hand, can be just refracted off the atmosphere without the use of satellites. Microwaves need those satellites if you want to travel around the Earth. All right, and that's it for using